Hello and welcome everyone to our second Tech Talk of today here at BASF booth at K-Fair 2019. And it is my pleasure to announce Piotr Puccio, who is the General Manager of Crop Design and Head of Trait Evaluation. And he'll be talking about the use of plants as a sensor to assess the impact of additives in greenhouse.
Yeah, thank you for the kind introduction.
Thank you for being here, and stage is yours.
Thank you. It is great to be here and great to bring something what is not plastic but real plant about which I would like to speak to you today. But maybe before I will start with the talk about the experiment we have done together with the colleagues from BASF EV, few information about the challenges. I think it is very obvious to all of us that the planet is fuller and fuller, and is getting fuller and fuller in the future as well. We will not stop it. So in 30 years, it is expected that we are reaching the threshold of 10 billion people, which to 70%, let's say 70% of us will live in cities. Some of the cities will be mega cities with 50 million, 100 million inhabitants. It is more than a country from which I came now, from Belgium. We will use 50% more energy, and of course these plants would need to feed us. So all these challenges need to be solved. And chemistry is an obvious enabler to meet all these requirements and the challenges, but agriculture as well. And my talk is how we bring the chemistry and the plant together. So we are using plant as a sensor. What does it mean? It is the same like each of us plant is feeling. Unfortunately, we cannot communicate, or it is not so talkative as the human, but we can read a lot out of the plant. For that, we use a technology we established in our company, so-called phenotyping, where we actually are imaging the plant. Now imagine you want to test materials for agricultural purposes, and you want to know what is the impact of these additives, for example, for greenhouse film on the plant. In our setup, we built a small tunnels, small greenhouses, which we put in our automated and digitalized greenhouse. Underneath, we have plants. For the experiment I will show to you, it will be tomato and eggplant. So aubergine. Then in daily or frequent imaging of the plant from the top, from the side, and from the bottom, we are imaging the plant throughout the entire lifetime of the plant. Because the plants are in the greenhouse, the entire setup is independent on the season. Usually in the field you would need to make it during a summer or springtime. In our case, we make it throughout the entire year. It is very cost efficient, very objective. The images do not lie. The proprietary software allow us to analyze up to 100 different agricultural features of the plant. During the setup is running in the greenhouse, the film is constantly monitored due to the so-called photosynthetic active radiation, and in addition, moisture and temperature. In such digital and automated greenhouse, with this imaging technology, we can again look on the surface of the plant. So actually what we see here as a surface, but with hyperspectral and multispectral imaging, we can look inside as well. So some of the physiological parameters of the plant can be measured as well. And this all in high throughput manner. So this frequent imaging gives them very nice, over time, inspiration about the productivity of the plant. Let me look together and show you a short movie how it is looking like. So our greenhouse is located in Belgium, near Ghent. It's 0.4 hectare under glass. And you can see the plant are moved the entire time throughout the entire greenhouse. And more than 20 different species can be analyzed. Some of the species are vegetables, some of them are staple crops like rice or wheat. In the greenhouse, we are using different treatments dependent on question we want to analyze. And all the plants are then analyzed, the phenotype is analyzed in this imaging setup, which is actually developed by our cells with the engineers working in the department. So we are combining different type of cameras from RGB, so the same you have in your smartphones, hyperspectral, and so on. And again, more than 100 features of the plant can be read. And this is very interesting because some of the features are linked, let's say, to the feelings or to the physiology of the plant. We are developing tools who are helping the scientists to go a little bit more inside the history of the plants as well. So smart greenhouse technologies is our philosophy. The treatment of the plants during the experimental phase depends on the scientific question. It can be treated with chemistry, can be treated with biologicals, and only one activity, and it is what you see here, is done manually. It is sowing of the plant. All the rest is automated. Of course, it is technology we use for field phenotyping as well. In this setup, the experimentation was done to analyze additives for the greenhouse, plastic greenhouses. And which results did we obtain? So first of all, we analyzed 3 different film compositions or 3 different additives, here as blue bar, red bar, and green bar. All the 3 different films were actually based on spectral information quite equal. There were not so big differences. Same about the transmittance, the PAR was more or less very similar. Nevertheless, the output is shown here. So first of all the plants tested, it was aubergine and tomato, showed more biomass. More biomass is actually this green part of the plant. All of them were bigger in this blue bar, under the blue bar film. Regarding aubergine, eggplants, no significant difference in yield. So the number of eggplants, the size of the eggplants was the same, but the quality of the eggplants, which were cultivated under blue bar film, was the best. It is actually the lowest, the better it is about the softness of the aubergine. Regarding the tomato, you can see here, the tomato, fresh tomato weight cultivated under the blue bar film was the highest in comparison to the other ones, and the total number of tomatoes was the highest under this film. So based on this data, we were able to show that the platform we created is capable to analyze additives for greenhouse technologies, for smart film technologies of the future. and thank you for your attention.